you want to try, take it as a homework, right? Draw the same circuit and try to mark the BQ point as the positive terminal connected to the battery and negative terminal Q connected to the negative terminal of the battery. Try that question and see, will the results change? And if you will have doubts to that, please make sure you mention it in the comments. We'll come back with the solution to that as well. Moving on to the next question. Next question, sir, 3-volt battery, I see that. Sir, they are asking the current. Sir, for current, battery is given, sir. Sir, I need to identify which of them are in series, which of them are in parallel. Sir, I don't know why, but sir, these two look that as if they are in parallel. Why? Because sir, they're both the ends are connected, sir, with each other. Yes. Parallel, yes. Take baby steps, as I mentioned. What will I get? Sir, 3-volt is here. And from here, my friend, we can write this down like this down like this. There is a 15 ohm in the middle like this. Sir, where is this 30 and 30 gone? 30 and 30, sir, the resistance equivalent will be 30 by 2. I told you, identical in parallel, divide it with the number of the resistors that are there. Sir, 30 by 2, 15 ohm is the resistance. So remove these two out. How much? 15 ohm, sir. Now, what is the resistance of this one? Sir, 15 ohm. What is the resistance of this one? 15 ohm. Now, sir, which one of them is in series and parallel? Again, understand and follow up what we learned. Sir, from the positive terminal, sir, believing that current will come out. Right? And sir, some of the current will go in this wire. I1. Sir, that same current, sir, will pass through this 15 also and this 15 also. Oh, so these two are in what? Series. These two are in what? Series. So replace, take baby steps. Sir, 15 plus 50, 30 ohm. My dear students, finally the circuit would look something like this. That sir, we have 15 ohm over here. With the 15 ohm, there is something connected in parallel, right? If you want to draw it like this, that is also fine. 30 and 15. Sir, finally I can see their ends are connected to each other, which are further connected to this battery also, which is 3-volt. Now, what will be the resultant of 15 and 30? Use the formula for parallel. 1 by Rp is equal to 1 by 15 plus 1 by 30. LCM, sir, will be 30, 2 plus 1 by 30. Sir, Rp will be equal to 30 by 3, sir, which is nothing but 10 ohm. So the answer to this question will be, sir, 10 ohm is the voltage, resistance, sorry, and voltage is 3 volt. So, sir, the current can be written as V by R according to your Ohm's law. So, voltage is how much? 3. Resistance is how much? 10. Sir, the answer comes out to be 0.3 ampere. 0.3 ampere. So, I hope you guys can identify, sir, which particular two of the resistors were in parallel. Then by removing that, sir, I can go to the next one, that which one is in parallel, which one was in series, and then that resultant of those two was in parallel with the last 15. Right? Moving on from this, a good example on how to identify in multiple circuits about multiple resistors, how and which one is in series and parallel. Moving on, and remember the concept. Always take baby steps while solving these circuits. Do not try to grab the entire question in one go. You will make mistakes. Moving on. Now, another good example. Now, why did I add this question? Only one motive is there. Sir, current, imagine, sir, is coming from A. Imagine this is a battery. Imagine, sir. Voltage is, sir, imagine V. Now, current comes out of this positive terminal. Yes. Sir, it will go and reach this point P. Now, my dear students, remember this thing. There are two ways of saying the same thing. I'll try to say it in both ways. Right? Sir, once the current comes to this point P, current wants to reach the negative terminal. Now, current, which is nothing but flow of charges, right? Now, charges want a easy life, easy path, easy way to reach the negative. What do you think? Now, they have two paths, sir. They can either to go along this or they can go along 5 ohm. But which one is easier? Sir, obviously the empty one, sir. Here the resistor is there, sir. So, my dear students, remember, this 5 ohm will get short circuited. Sir, why? Because no current will pass from that. Whatever current comes from here will pass through this 5 resistor and go to the negative terminal. One way of saying it. Second way of saying it. Sir, teachers told me in the starting of the chapter that current only flows when the potential across the 2 points is same, is different. The potential difference should be there, then the current will pass. Now, if I connect an empty wire, connecting wire across the two ends of this particular resistor, obviously the potential of Vp and Q, Vp is equal to Vq, sir. And potential is same. Sir, that means potential difference will be 0. Potential difference is 0. That means the current through this will be 0. So what are we left with? Only, sir, two resistors are there. One that 5, one this 5, and we have a battery that we imagined. Sir, 5 and 5. Sir, what is the question? Question is asking that what is the equivalent resistance across these 2 points. So, sir, this one gone, 5 plus 5. Sir, R equivalent will be 10 as both of them are in series. As both of them are in series. Interesting and conceptually solid you should have to be to understand and identify such special cases. Whenever you see that, sir, a particular resistor has 2 of its end connected with the empty wire, with the connecting wire, understand, my dear student, that that is there to be gone. It should be short circuited. Remove that and relate and go and study the remaining, all the entire resistors and the circuit that is there. Moving on to the next one. Now you have another circuit. All of them are 3, 3, 3, 3. Done, sir. Sir, how to identify? See, they have marked the current also. Here, current is going from this one. Agreed? That current that will pass from this will also pass from this, sir. Same wire, sir. No junction in between. Oh, are you trying to say that these two are in series? Yes. Yes. Let's pace it up, because now I hope you guys can get along with me. Sir, this 6 and this 3, if I remove these two and replace it with 6, sir, this 6 and this 3 will be in parallel, because their ends will be connected to each other. And sir, if I connect 6 and 3 in parallel, sir, 1 by Rp is equal to what? 1 by R1 plus 1 by R2. That will be how much? Rp will be equal to 6 by 3. That will be 2 ohm, my dear students. Understand this. So that means, sir, are you saying now this will 2 removed? 6. 6 and 3 both removed 2. So what will be left in the circuit? You will be left with the single battery along with your 3 ohm that was there, and this entire side, right side, gone. It will be replaced with 2. So you will get 2 ohm, 3 ohm, and this one 3 ohm. Sir, 3 of the resistors, sir, I see, and they all are, sir, looking to be in series, because whatever current will come from here, sir, it will end up passing from them and reaching the negative terminal. So my dear students, the R equivalent for this circuit will be 3 plus 3 plus 2. So the total resistance will be 8 ohm. Check it out. Check it out. Easy question, but yes, identification of series and parallel, that is very crucial. And I hope you guys now got the eye to identify that, sir, these two are in series. Once I remove these two, then I can remove it and replace it with this, and that one will be parallel with 3. If you're getting along with that, good. Let's move on to the next part. Next question, another interesting question and a standard question. What exactly it says? Sir, 3 resistors, direct question they want, are equivalent from us. Now, first thing first, please do not get excited when you see such a question. Oh, sir, all 3 are in series. Sir, R plus R plus R, sir, 3R. Relax, my dear students, relax. This is physics, right? This is physics. So we need to be a little bit more focused. Check it out. Sir, why you are saying these are not in series? Let's understand. My dear students, understand this point, that, sir, this is connected to a particular point, let's say A point. Then, sir, you connected this empty wire. Yes. Empty wire makes the potential of 2 points to be same. So, sir, are you saying if the potential of A point is something, the same potential will be of this point also. 100% yes. Connecting wire, empty wire, makes the potential of 2 points where you are connecting them to be same. So if you connect this empty wire starting from here and connecting it here, that means both the points have the same potential. But sir, I do see another one also. This one also, sir, I see. Sir, this is B point. Yes, B, B. If you have done this, I believe now let's come to the art of redrawing the circuit. How? Check it out. Sir, A and B. Sir, there is a resistor. First resistor I see, that is between A and B. Check it out. Sir, left end has potential A and the potential of the other end is basically B. First resistor, done. Sir, but what about the second one? Second one. Sir, this is also between A and B. Oh. So, are you saying that I can draw that one also like this? 100% yes. 100% yes. Because, sir, both the ends of these are also at a potential difference maintained by A and B. And interestingly, sir, I see the third one, sir. This is also between A and B. So, sir, if this is also between A and B, oh, are you saying that I can place this one also like this? Yes. Always remember, my dear students, empty wire you see, follow the path and you can say all the points have the same potential. Empty wire you see, say all the points on the empty wire have the same potential. And once you do that, then identify, sir, between A and B, sir, one resistor. Sir, between A and B, another resistor. Between B and A, another resistor. All of these are in parallel. This appears to be series, but this is parallel. Be very, very careful with specifically this result, because this is a standard question, my dear students. And if three of them are in parallel, sir, R equivalent is equal to R by 3. Sir, R by 3. Didn't I tell you that if you have identical number of, identical resistors, then you can directly write the resistance divided by the number of resistors, R by 3. That is the final result for this one. I hope you could absorb the information that by connecting, in last case also, we did the same thing when you short circuited. By connecting a connecting wire which is empty, you are making the potential of multiple points same. And when you do that, then you can restudy the entire circuit accordingly. Moving on to the next question. A set of n identical resistors, each of resistance R, are connected in series and the effective resistance is found to be X. Oh, X. Okay. Moving on. When these n resistance are connected in parallel, the effective resistance is found to be Y. Now, first of all, find the ratio of X to Y. So, sir, they are clearly mentioning that n identical resistors are there. First, each one of them is having R. So, sir, X, I'm directly writing that series combination, sir, will be R plus R plus R plus R. How many R? Sir, n Rs. How many Rs? N Rs. Sir, n Rs will make it n into R. Easy. Sir, how many Rs you are basically adding up? N number of Rs are there. Sir, but what about Y? Sir, they are saying when they are connected in parallel, then the resultant is Y. So, my dear students, 1 by Y, 1 by Rp is equal to 1 by R plus 1 by R. Sir, how many? N. N. So, sir, if I take 1 by R common, so 1 plus 1 plus 1, similar to what we did in the starting. So, sir, how many total are there? N are there. Sir, how many ones are there? N ones are there. So you will get N by R. You will get N by R. So, sir, 1 by Y is equal to N by R. So Y will be equal to R by N. So the resistance of the series combination, when each of R are connected, N number are connected in series, NR. When they are connected in parallel, R by N. Now, what are they asking? Find the ratio of X to Y. Sir, X to Y, easy. NR divided by R by N. Sir, denominator of the denominator will jump up. and R will get cancelled. N into N will become N square is to 1. So my dear students, the ratio will be N square is to 1. Check it out. Easy question, right? But again, be very intact with your basic formulas and basic understanding, right? Sir, R is the resistance of each N times. Add it up, NR, right? 1 by R, sir, N by R. But 1 by Y is equal to, sir, N by R. So please remember to reciprocate it, right? So Y came out to be R by N. I hope this question everyone could find it out, and this is another standard question. Please believe that if you have seen some question that comes to the boards, your confidence level shoots up, right? That is the entire game. Whatever time we have right now before the exams, make sure to go through maximum number of problems. The maximum number of problems you see, the better your confidence will be while you write the exam. You see something identical that is already done, you will have a booster in your confidence that yes, I have seen this, I can do it. Doesn't matter even if they are changing it a little bit here and there, you will be able to correct that out. Moving on to the next question. Question is, they are saying 3 identical bulbs are there which are connected to a battery as shown in the figure. When the circuit is closed by means of the switch S, which is marked over there, it is found that, okay, easy question. First of all, please understand one thing there, because talking about the brightness, if you don't know by now, remember the brightness of any bulb is directly proportional to the power that it dissipates. So please remember, if ever we have to comment about the brightness, that which bulb is more brighter, then try to hunt for the power of that dissipated by that particular bulb. Now here, although it's a very easy question, I will tell you directly how to go for it. Does not matter what is given and what is not. What matters is your understanding of the reading of the circuit. Sir, there will be some resistance they have? Yes. Are they all 3 identical? 100% yes. Sir, whatever will happen, I don't know, but one thing is for sure, current will come out of the positive terminal? Yes. After it passes through P, because entire current will pass. Sir, after passing through P, this will divide. Oh, sir, how will it divide? Sir, because they are identical, please do not assume that this is the situation always. Never. Only because Q and R, they are identical bulbs, which makes me understand that their resistance will be same. Both the paths current will have to follow, and basically you can say they have to resist, they will be resisted equally. The flow of charge will be resisted equally. So charge will decide to equally get distributed, or current will decide to be equally distributed. I by 2, finally I will come out of this terminal from this side and go to the negative terminal. So what do you want me to understand from this, sir? I want you to understand that how the current division takes place. From P, the total current I passes, but from Q and R, half of the total current is passing. And I think by now every one of you must know that power is equal to what? I square R. More the current, because resistance for all 3 is same, right? Now why am I not using V? V square by R. Because potential across them is not going to be same. Not going to be same. Right? If you want, you can write this down, the resistance to be R and R. Sir, this resistance of the entire thing will become R by 2. This is R. So resistance potential will be different across Q and R and across P. Q and R will have same potential difference across them, but potential difference across P will be different. Not getting into that, because we can directly say that I understand that power is directly proportional to current. Sir, more the current, more will be the power. More the power, more will be the brightness. So now check it out. Sir, current was maximum from which one? Sir, P. Current was total, I current was passing from it. But sir, what was the current passing through the other 2? Half. That means that, sir, if I compare these, sir, from Q and R to, sir, the current that is passing is same. So their brightness will be same, but compared to P, their brightness will be lesser, right? That will be lesser. How much lesser? 1 by 4 times. Why do I say 1 by 4 times? Because current is half and power is directly proportional to the square of current. But that is not the question. So question says that R will be bright, P, Q and R all will be equally bright, Q and R will be immediately burnt out. No, P will be bright but Q and R will be dim. Comparatively they will be dimmer. Right? They will be comparatively dimmer as compared to P. So P will be the brightest and R and Q will be dimmer compared to the P1. I hope this small concept of how the current division takes place and what the brightness, basically which factor determines the brightness, I hope you guys can absorb this from this question and move on. Let's move on. Question number 17. Again, see this, right? Sir, how do you identify? See my friend, all the points are connected with the empty wire, connecting wire. When you have the 3 points or 4 points that are connected with the connecting wire, empty wire, understand, sir, same potential. You can even make it a single point to make it look something that you are more familiar with. I'll redraw it for you guys, right? So sir, if this is an empty wire, sir, this is also empty wire. Do it, make yourself happy, right? Let's start to redraw it. If I was you, they are saying that, sir, they are joined 5 coils, each having the same resistance. Resistance is same, are joined, and they are saying the resistance between P and Q, R equivalent is given. R equivalent is given to me. So they are saying what is the resistance of each coil. Let's assume that each of them have resistance R. Done. If their resistance, each one of them is R, let's redraw it. Sir, you said that these have the same potential, P, 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 P. If you have the points with the same potential, make it a single point, nothing will be hurt. Right? So, sir, P, 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 sir, these are Q, Q points, but sir, there is a point in between. Arey, don't worry. Take it as X. Take it as X. Now, if I say these 4 points are P, sir, between P and X, how many resistors are there? First one, second one, third one. On the left side, they all have P. On the right side, they are connected to X. Oh. So, sir, are you saying, can I do this? 100%, my dear students. You can draw it in the way that you are more comfortable. Right? I think this is something that you are more used to looking at when I say parallel. So, sir, R, R, and R. Now they are in parallel. Oh, but sir, others are also there. Yes. Sir, but there is one between X and Q also. Sir, between X and Q. Oh. Like this? Yes, yes. And but sir, last one, sir, between P and Q is there one. Directly from P, draw it to Q. Check it out. First of all, I hope you guys understand that how are we ending up redrawing the entire circuit from that to this. One thing I can assure you that whatever that circuit is, this is also the exactly same circuit. Right? So now it's just that, sir, this is visually more pleasing to me just because I am used to seeing the parallel like this, sir. Now, my dear students, baby steps. R, R, R. Parallel, sir. Parallel, sir. R by 3, sir. You told identical. R divided by the number. So that means I can remove them and, sir, I can replace them with what? I can replace it with R by 3. Again, I will not be in any hurry. I'll do one thing. That's a P. This is Q. So this has turned into R by 3. This is the point X that was there. And sir, between them, P and Q, one more R was there. Now, I think you can clearly see, because we are finding across P and Q, batteries are connected here, my friend. So, sir, now R by 3 and R are in series. If they are in series, sir, that means the resultant will be what? R by 3 plus R. That makes it 4R by 3. And last but not the least, sir, 4R by 3 and this R, sir, they will be in parallel. I can remove these two and replace it with 4R by 3. And that 4R by 3 and this R will be in parallel. right? So sir, what will be the final result? 1 by rp is equal to 1 by r, and what is the resultant of this entire thing? 4r by 3. So please write it down as 4r by 3. Now LCM, sir, we know how to take that. Multiply with 4, sir, rp comes out to be 4r by 7. 4r by 7. The question was not to find out the resistance. They have given you the equivalent resistance is 1 ohm. If they have given you the equivalent resistance to be 1 ohm, then we can say that, sir, this RP that I am getting, the final result that I am getting, sir, this will be equal to 1, sir. And that means R is equal to 7 by 4 ohm. R is equal to 7 by 4 ohm. Now check it out. We have option 3 right in front of us. Everyone, please make sure you pause and absorb the entire information. These are some of the best circuits that they can ask to you guys in 2026 boards. So make sure that identification of series and parallel is something we need to get better at if we are going to deal with some numericals from electricity. And this method of redrawing, I hope I could revive that with these questions. Moving on to some of the last questions. Sir, again, I told you that, triangle is something that people get confused with. But now, no more confusion. Sir, if I look at this circuit from the far away, sir, I can identify, sir, that current, if it will come from A, right? Believe that current comes from here, sir, it will split from here. Some current will go up, some current will go down. But one thing is for sure, whatever current will go, sir, from this one, it will be same from this one. Redraw, my friend. That means, sir, are you saying these two are in series? 100% yes, I'm saying that. Right? So if these two are in series, the redrawing of the circuit would eventually look like this. That, sir, there is a resistor R, there is a resistor R, there is a resistor R, and sir, you made both of them as 2R. 2R, R, R, R. This is the final circuit. Now, again, my friend, two terminals of two resistors, I pakka see, they are connected to each other. If they are, oh, they are in parallel. They are in parallel. So please understand, sir, these two are in parallel. 1 by Rp is equal to 1 by R plus 1 by 2R. Take the LCM, my friends. Again, multiply with 2. So, sir, Rp will be equal to 2R by 3. So I can remove these two and replace it with 2R by 3. Yes. Sir, remove them. Remove them. What will I get? I will get a single R, a 2R by 3, a single R. Sir, R, 2R by 3. Sir, 3 of them are in series. So I can say the final equivalent will be 2R plus R plus R. 2R plus 2R by 3. Sir, that will make it how much? 8R by 3. Check it out. 8R by 3. Option third is the correct option. Right? Now, please understand that whenever we see such a circuit, we should not be panicking and we should not be believing that this is something new. Always believe in redrawing the circuit, and if you get better at redrawing the circuit, I can assure you that any difficult circuit can easily be dealt with. Moving on to the last question. Some of the last questions, 1 or 2 questions are left. If a wire of resistance 1 ohm is stretched, okay, stretching is done, sir, and double its length. Now, one thing I'll tell you, most of the students make this mistake that, sir, double the length. Sir, R is directly proportional to L, sir. So direct relation, double the length, double the resistance. Khalas, done. No, relax. Again, stretching is done. Stretching is done. A wire is stretched. Now you tell me, if I take a wire and, sir, I stretch it out, if I increase the length, do you realize that, sir, with the increase in length, sir, the area of cross section will also drop down? I say yes or no? If you stretch the wire, do you realize with increase in length, the area will become lesser? But one thing remains constant, the matter, the volume of the wire. Sir, what is the volume of cylinder? Sir, they told me pi r square h. Pi r square h. Can I directly say pi r square was the area and h is the length? Yes or no? Yes. So sir, new length they are saying is how much? 2L. Do not neglect the change in area. Imagine the new area is A dash. Imagine the new area is A dash. Sir, if you have a stretched wire, the area will also decrease. The length has doubled. So what is one thing that remains, sir, constant? You said volume. Sir, volume is what? Pi r square, which is area, into the height, which is length. Oh, are you saying that area into the length is going to be same? Yes. But what is the new area? A dash. Sir, what is the new length? 2L. I say yes or no? Right? So sir, if I equate this, because volumes are going to be same, you cannot, sir, you cannot say that new material got produced by stretching it. No. It doesn't work like that. Volume remains same. So length and length gets cancelled. Oh, sir, A is equal to A dash into 2. So A dash will be equal to A by 2. Remember this. And this is a fact I can tell you one. If the length is increased by certain factor, the area will drop down by that same factor. Always remember this. Do not neglect the change in area due to the change in length. If you are stretching it, if you are compressing a wire, area will increase but length will decrease. Do not neglect the changes due to one particular dimension. Sir, what is the change in the other quantity or the dimension that we have? So here, sir, are you trying to prove that if the length has become 2L finally, the area will drop down to A by 2? Exactly my point. If that is the case, now I don't think it is difficult for us to understand. They said, sir, initially the resistance was 1 ohm. So initially what was the area? A. Length was what? L. So sir, R was equal to rho L by A. This was equal to 1 ohm. Given data. I did not mark it by myself. Given. Then the resistance will be, when I stretched it to the double length, sir, new resistance. Yes. Sir, that will be, am I changing the material? No. Material is same. So that means resistivity will remain same. 100%, sir. Resistivity though depends on the material, sir. It does not depend on what is the length or area. Resistivity is the intrinsic property, they say, which does not depend on the dimensions but only depends on the type of material that you are using. So that means, sir, rho though I can take same, but length got doubled and area got dropped down by A by 2. Take the 2 up, 2 into 2, rho L by A. Oh, sir, this though I know, sir. Rho L by A is 1. If that is 1, my dear students, 4 into 1, 4 ohm will be the new resistance of this wire. So please remember again a bullet point that we take away from this question. That if the length is increased, if you are comparing two different wires, then you don't have to worry about it. But especially when you are stretching a wire, changing its length, do not neglect the change in the area of cross section due to the change in the length of the wire. Remember that. And simple trick to remember, sir, if the length increases by n times, now n can be anything. If the length increases by n times, the area will drop down by the same factor. If you doubled the length, area became A by 2. If you triple the length, area will be A by 3. So please remember these very crucial points. Moving on to the next question. We have an electrician puts a fuse of rating 5 ampere. Is that the part of the domestic electrical circuit which is having power is given, sir? Yes. Kilowatt, sir, power. Voltage is also given? Yes. Is operating. What is likely to happen? Now what they are asking you, that will this fuse be okay? Will the fuse allow this current to pass. Sir, how does it work? First of all, power is given. Yes. Sir, write it down. 1.5 kilowatt. First, sir, are we looking for energy here? No, 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 no. If you don't, convert it into SI. 1.5 into 1000. So that will be 1500 watt of power. Done, sir. Agreed with you. That kilo means 1000. So you removed the kilo, placed the 1000. And now, sir, voltage is how much? 220 volt. Voltage is how much? 220 volt. And sir, someone told me few minutes back that we can easily find out that what will be the power and relation of voltage plus the current. P is equal to VI. P is equal to VI. Sir, current can be written as power by voltage. Sir, if I place power, which is 1500 divided by 220, sir, 0, 0 cancelled, 150 by 22, which I can write it down as 75 by 11. Sir, 75 by 11. Sir, cancel it, sir. We will get what? 6 point. 6 point. You will have 9. So almost 90. So 8. 6.8 something. 6.8 ampere. 6.8 ampere. Now, this is the current that this particular electrical heater will try to fetch. And what are you placing what is the rating of the fuse? 5 ampere. Will this work? No. Why? Because, sir, fuse is always before the appliance. Right? This is whatever your appliance is. Sir, your fuse is before that. Right? Now, when your 6.8 ampere of current will try to pass from a 5 ampere rating of fuse. Sir, more current passing from this means that this particular wire will melt. This will break the circuit. This will break the circuit from here. Right? So, sir, if it will break the circuit, that means eventually no current will pass. So the answer to this question is that, sir, the fuse will be melted once this is connected. And they are asking that what are the changes that we can make? Always remember, sir, we should always use a fuse which is little bit more, having rating of current little bit more than required. What is required? 6.8. So at least, sir, I think your fuse rating should be at least 7 ampere. Right? Always remember, little bit more. Right? So here we were getting, sir, 6.8, little bit more than that will be 7 ampere. Always remember that. Right? Because 5 ampere when you placed, sir, 6.8 ampere of current came, melted it. More current, more heating effect. More heating effect, fuse melts. Remember that. Right? I hope the point that I wanted to give you through this question very well communicated through this. Moving on to the last question. Two lamps, one rated at this and other one rated at this, are connected in parallel. Now, please understand this part. Right? And this is an important last fact that I want you guys to take away from this lecture. Rated voltage. Rated voltage. Sir, rated voltage? Yes. See, when you bring a bulb at home, right? I said that I brought a 100 watt bulb. Now, please guys, mind you, it's not that always it will dissipate 100 watt power. Sir, why? Because that 100 watt power is specified to be dissipated at a particular voltage. That is why when you see that, sir, on certain appliances, I see they write it like this, 60 watt dash 220 volt. So what do they mean to communicate? This is the power dissipated through the particular appliance when 220 volt of potential drop is given across it. Oh. So that means, sir, is it possible that 60 watt bulb, if I use it in some other circuit, the power will be something different than 60? 120% possible. Right? But if you place it across 220, then this is the power. Clear? Now, they are saying that another one is 40 watt, again rated at 220 volt, right? Again rated at 220 volt. are connected in parallel across the supply of 220 volt. Good part is that in this particular question, they have not tried to manipulate it, and they have kept the same potential that basically was required for them to dissipate these particular powers. Draw the circuit diagram. I think we are good at it. Sir, the bulb looks something like this, sir. We can write 60 watt, 220 volt, right? And another one connected in parallel like this. Sir, 40 watt, 220 volt. Check it out, my dear students. Right? Now, they are connected across 220 volt battery. Connect the battery across their terminal of 220 volt. Check it out. First part, they just wanted you to draw a circuit diagram in which two of these bulbs were there, and obviously the battery they are connected across is 220 volt. What is the B part? Calculate the current drawn from the electric supply. Oh, sir, current is needed, sir. Sir, if I know the resistance of these two, sir, will it make my life easy? 100% yes. How can I find out the resistance? And I always tell the students one thing. If you are ever given this thing, know that power is this much and 220 volt. Please remember, my dear student, this is an indirect way of giving you the resistance, because resistance can be written as V square by P. How? Power is equal to V square by R. So can I say, sir, R brought to this side and P goes to the other side. So it will be V square by P? 100% yes, we can. Sir, we will get 220 square by 60 from here, and which will be your 48400 divided by 60. Right? You can calculate this. This will come out to be 2420 by 3 ohm. Please check the calculation once for yourself. And sir, this is the resistance of the first one. Right? So this was the resistance for the first one. Sir, what about the second one? Second one is having a resistance of V square by P again. But now, sir, V square will be 220 into 220, but power is 40. So you will get 4840 divided by 4. 4840 divided by 4, which will make it what? 1210. 1210 ohm. These are the resistance of both the given bulbs. Right? Now, what do you want to do? Sir, we want to find out the current drawn from this. Right? Now, see, understand one more thing. Is there someone who is wondering that, sir, is there an easy way that we can figure it out? 100% yes. Right? So please remember, either so you go through the resistance and find out R1 and R2 and then say that they both are in parallel. One way. Second alternate way is what? That sir, voltage across them I know. Right? Now, why do I always tell the students to prefer that method? Because see, here you got lucky that same voltage is there across them. Right? But if this voltage gets changed, then it's preferable to go by that method. Sir, voltage is 220. I know the power they dissipate at 220 is what? 60. So can I say that I1 will be how much? I1 will be, sir, P1 by V. Right? Because power is equal to V into I. And same way, sir, I can write down that power was what? Sir, 60. What was the voltage? 220. Sir, can I cancel it? Yes. 3 by 11 ampere will be the current that will be passing through this one. You know the power dissipated across this, you know the voltage. Same way, sir, I2 will be what? Sir, I can say I2 will be power dissipated by the second one divided by voltage. Sir, how much is the power? 40, my friend. 40 divided by how much? 220. That will be, sir, 2 by 11 ampere. 2 by 11 ampere. Now please remember, they are not asking what is the current in the first one and second one. They are asking the calculate the current drawn from the supply. So total current, sir, is what they are requesting us. Total current. Sir, the current in this plus this. Because the total current must have come over here and split into two parts. So I can write down I is equal to I1 plus I2. Sir, if I add 3 by 11 and 2 by 11, I will get 5 by 11 ampere. Understand this. Second part, the answer will be 5 by 11. Sir, what if I go by this method, R1 and R2? No problem. You can say that they will be in parallel, and if they are in parallel, sir, I can get R equivalent. Voltage is known. Use Ohm's law. Use Ohm's law. Calculate the total energy consumed by the two bulbs together when they operate for 1 hour. When they operate for 1 hour. Now, I think we know one thing, that sir, the power they are dissipating, because they are connected across the same potential they were rated at. So sir, the powers I know already. Now they are saying that how much total energy they will be consuming, right, in 1 hour. So always remember, sir, we can write down the energy consumed in the first case. For this one, sir, power into time. Now, if you are wanting to find it in kilowatt hour, although here there is no mention to find it in commercial unit, so you can directly say 60 into 1, or sir, I can divide it with 1000 to convert it into kilowatt. Power, convert it into 1000, although here there is no compulsion, they have not mentioned. So you can use any units that you want, right? Either so you convert this into kilowatt and write the final answer in kilowatt hour, or sir, time also, sir. Can I convert time to seconds? 100% yes, right? 1 hour, 3600 seconds. 60 into 3600, that will give you your answer in SI unit, that is joule. Right? But anyways, I am writing in kilowatt hour. So sir, we will get what? Sir, this 1 0 will get cancelled. 0.06. 0.06 kilowatt hour is the energy that is basically used across first one. And same way, sir, power, your energy used across second one. Sir, I can write it down that will be equal to P2 into T. So time for both of them, they said, is 1 hour. Calculate the total energy consumed by the two lamps together. So sir, P2 is how much? 40 into, divide by 1000, sir, kilowatt hour, right? Time is 1. So you will get 0.04 kilowatt hour. The question is not over yet. They asked the total energy consumed. So my dear students, remember the total energy can be written as sum of both of them. Sir, 0.06 and 0.04, that will make it 0.1 units, or you can write it down as kilowatt hour. Check this out. Check this out, right? I hope that this session was fruitful for you guys. I hope some of your doubts got clarified through solving these numericals. And I hope you guys very well by now understand that to get better at these numericals, we need to practice as much as possible, right? This was a variety of questions that you can expect in your upcoming science board exams. And we will again bring another chapter for you guys where we'll be discussing more numericals, right? And also, if some of the students wish to listen to the formulas and the theory in one shot, you can also please comment down below, and we will surely make sure that we bring your demand to the plate. So all the best to all the students. I hope this entire session was fruitful for you. Now it's your part. You have to multiply your concepts by practicing more questions on the similar concepts. All the best. See you guys very soon. Thank you so much.